Thank you very much. So unfortunately, it looks like the fonts have suffered a slight bit of damage there on the presentation, but that's okay. It is going to be spreadsheet of death. So my name is Andrew Boag. Thank you very much for the opportunity to present here. I'm the Managing Director of Catalyst IT here in Australia. Is that going to work? Yep. Okay, cool. So just about us, Catalyst IT, we're all about open source technologies, right? That's what has, so these are some of the tools that we work with, but we're sort of engineers and we've chosen open source technologies as the best way of providing solutions to our clients and our partners, and we have offices in Australia and New Zealand and the UK. You can see there the sort of the HQs in New Zealand. And this brought us to Openstack, right? So we were very much involved in the open source movement prior to Openstack, and we moved to, and then we started to assess and review open source cloud platforms, and we were involved in all sorts of stuff on the edge of this prior to that around virtualization, using open source tools, and managed services using open source tools, and we're very much a Linux shop. And we, 3 years ago, I don't know if Andrew Ruthven's here. 3 years ago, we launched an Openstack public cloud in New Zealand, which was the first truly public cloud in New Zealand, and that's been going strong, very, very strong ever since. So, and as well as that, we provide some level of Openstack consulting services, among other things. I myself was once upon a time much more operational and actual knowledgeable about engineering things, but now I just sort of, that's pretty brutal what it's done to the slides. So I just want to have a slight sort of meta talk about this talk, right? I'm really trying to make this reasonably big picture and an overview. It's not about comparing performance details or technical differences between different object storage and file system models. So I'll just give you a heads up. I'm going to sort of I'm going to cheat a wee bit when I talk about disks and file systems and block devices. I'm sort of going to use them all interchangeably. And I realise there is a difference between these things, and if you really want to come and talk to me afterwards and have a long discussion about the difference, you probably know more about it than I do. But I understand there's a difference, but for the point of explanation, we're sort of using these things interchangeably. Minimal tech talk, if possible. It's more about sort of pragmatic use of technologies and what this means from an operational point of view. I'm going to be a little bit generalised. Once again, you can pull me up on that if you feel the need. And this does sort of this talk does contain an idealistic view of a utopian storage scenario. And there's some radical thoughts in here potentially as well. So when we talk about storage, okay, so we're just talking about storing something digitally. And let's forget about how we store it. Just something being stored digitally, whether it's just like 1 byte or a big video. Okay, so the range of things. So I thought about I actually added one of these today after watching Jonathan's keynote. What are the sorts of things? And there is no solution that gives everything here, right? These are just some of the descriptors that we think about when we're talking about digital storage. So availability, right? Like it has to be available somehow, some way. These things could be applied to anything from a physical drive to a tape to potentially a running disk to a cloud storage platform, whatever. So it's available. Okay, that's something we think about. Consistent, right? A big part of the way we store things and so the criteria for things is that when we store it once and we come and look at it again, it is the same. Okay. Resilience and durability, tied to consistency conceivably, but means that it stays the same and it isn't affected by adverse things, right? And in the real world, that could be all sorts of things. That could be physical damage based on something sort of shaking the disk, based on sort of bit rot, based on all the way along the line. Redundancy, a word that gets used a lot when we start talking about infrastructure and storage around, tolerance to failure. Locality, important in some cases, is your ability to be proximate to the data, to potentially even hold the physical device that is the data itself, to hold the disk in your hand, to control the power supply to that disk, to be able to meaningfully delete all copies of that disk, all copies of that digital asset. Performance, of course, and I sometimes think performance sometimes tends to hijack a lot of the discussions around storage in some spaces. Capacity, of course, we're always running out somewhere, and security and access control, of course, right? We do care a lot about those sorts of things. Throwing this in there, a definition of a complex problem is one by which, this isn't my definition, it's one by which when you start proposing solutions, you end up changing the problem, right? I like this because often in the sense of engineering and architects, when we start hearing about a problem that isn't a simple one, we start thinking about ways we can solve it, and inherently, we slightly, sometimes a lot, sometimes a little, we change the problem, right? A simple example is moving from local storage in a file system, traditional architecture, one box, we've got a local file system, and then we decide we need more capacity, so we put 2 front ends and we put a network file system behind it. Now, at first glance, I mean, this is very much the way it has been done for a number of years. At first glance, things are all pretty much the same, and we've solved the problem of capacity, but network file systems are slightly different to local file systems, and there are some implications, and there are some things that now used to work perfectly before, but might have some problems now. We might not know that straight away, but now we realise this a bit more, but we change the problem by proposing a solution. Just one small section on SANs. I'm not going to talk about SANs here. This isn't what this talk is about. But who here is responsible or uses an infrastructure set at the moment that is using a SAN? Okay. So what problem do SANs solve from anyone? Anyone want to sing out? I'm not going to give the answer here. I'm just interested to what your answer is. Anyone? Performance. Absolutely. Scalability. Anyone else?
Too much money.
Too much money left in the budget. They certainly solved that problem. They certainly solved. Also, they solved the problem of not having anyone left to run a procurement process for the next SAN that you're going to buy. Right? That's it. No, true. I mean, SANs are awesome. SANs solve a lot of operational problems, absolutely around performance. There's some blistering performance you can get out of SANs. The problem I've seen them solve is that when things went from a lot of physical machines and racks, the very traditional PET setup, to a VMware cluster with a SAN, there was a lot less overhead required for changing disks. Right? So there was a lot more redundancy built into the SAN, which meant you just had more reliable baseline performance, and it was easier to provision new disks. Right? So there was that was the benefit I saw. Abstraction, yeah. They do have their downsides, though. So, file systems are everywhere, right? The traditional concept of a file system, it's on your phone, it's probably, and there's numerous in your car. Many of the Internet of Things have some sort of file system running in them. A small one, Raspberry Pis have them, your disk has them, your laptop has them. Obviously, all the servers that are running inside cloud platforms essentially have file systems running. That's how we build things, is we use the file system underneath, even if it's been abstracted away. I mean, it's a very mature and known thing. There isn't that much exciting development going on. I mean, compared to other spheres of IT inside file systems, right? It's a reasonably solved problem. I mean, there is some movement, but there's not big commercial, expensive file systems that people are selling. If you discount things like network storage and that, I mean, the file system is I certainly would never pay lots of money for any solution for just a file system that runs on a disk, because I don't see the argument. Objects. Now, so just actually, when I say file systems, I mean the standard thing that is your C drive. You know, it's got a hierarchy, it's got files, the thing that everyone understands, the thing that even the least technical person, they understand how file systems work. Bucket objects, that's more of the concept of an object, and I'm sure you guys all understand this, is a bucket, and you put an object in it, and you don't have all the same concepts of hierarchy and importantly consistency and also capacity and knowing where these things are and other differences as well. But all you need to think about in terms of this asset is which bucket it's in and what it's called. So the good thing about file systems is they're very familiar and they're very well known. So if I give you, right then, perfect example, I handed a file system to this gentleman in the back and I said the presentation's on this file system. And he found it, and there it is, right? Like I handed a small bit USB drive that was created on a Linux machine. I didn't have to say, what version of the operating system are you running back there, and when was it produced, and has it been patched, and you have to enter this code to get the information out. It was very simple, right? I said it's in a folder called pres, and away he went. And even if I hadn't said that, he more than likely would have found it. So that's pretty amazing, you know. It doesn't matter which operating system you use or which computer you use, it all just sort of works, and we sort of know how to use it. But they're not perfect. You know, file system disks, they're fragile. They can get corrupted. They can break in grandiose ways. They fill up, which has real implications. They have, I don't like saying things aren't scalable because everything's scalable if you invest money in it, but they have scaling considerations. And it's quite easy to use block devices badly and inefficiently, especially if you're talking about network and virtualized storage. And I don't really have time to talk about that, but there's reasons why you do things in inefficient ways. And I believe that the arguments for using virtual block devices inside things like Openstack or AWS, that's not the way you should be architecting applications. It's not going anywhere, and if you lift and ship applications into a cloud, it's unavoidable in many cases, and we still do it, but if you're building applications, you should be building them to use less and less of big block device storage. They should be using other storage models. So why is object storage better if you shouldn't use block device storage or file systems inside a cloud architecture? Capacity management is easier, right? Really, inside a data center in a rack, especially legacy, especially before SANs, and the downside of SANs is they're sort of quite expensive compared to just putting disks in machines, is there was always these talks about disk filling up and putting new disks and replacing disks and having to deal with that sort of operational stuff. And it still goes on, and that's not a trivial amount of overhead and monitoring. Like, you have to be paying attention to these file systems and detecting the fact that they might be running out of disk. And that's still something that we're dealing with at the moment, even though we've got a lot more tools to be able to make flexible sizes of file systems, right? You can change the size of them online, and you can do all sorts of stuff, but there's a cost implication and there's performance implication. Object storage gives some really powerful physical redundancy capabilities, which, you know, if you want to come and talk to me about, then fine. It just more powerful than block devices, but with some trade-offs. You can put metadata and taxonomy with objects in arguably a more elegant way. That can also be done with file systems. I think one of the strong arguments as well is that object storage is very portable, right? Like, if you put all your stuff into S3, which was sort of the first object storage, Amazon, you know, unless you're doing things really exotic, you could pick that up and put it somewhere else without too much of a big deal, because it's just buckets and objects, right? Like, you'd have to export it and you'd have to ingest it, but that's something that wouldn't be that crazy to plan and would be quite easy to monitor. It's definitely cheaper if you do it properly, and it's not just about comparing the amount of gigs you're using or capacity you're exposed to. It can be demonstratively cheaper. The catch is you can't put everything into object storage. Objects are immutable. They cannot change. You can only add and delete. You can't update, which is fine for some things, but problematic for others. Many enterprise applications don't support objects natively, so you can't just take an application and start pointing it at object storage. It doesn't work that way. It doesn't work for small files that change a lot, that are transactional, for example. That's not a good use case at the moment for object storage. This whole idea of eventual consistency is a bit of a brain melt, right? It isn't really the way we're used to writing applications in some cases. Sometimes it's not a big deal, but sometimes it really is a big deal. There's certainly, we haven't had, you've got to be a little bit selective about what you do with objects. And there is a latency cost sometimes in terms of fetching. It's not the same as a file systems. File systems are very snappy. You can write files and read files and change files and edit files. That's not the behavior you will always get from an object repository, but your application needs to understand that. So it's the options for you, and there are many, but Openstack Swift. Now, Openstack Swift is an interesting one in that it is one of the few, I don't know if there's another OpenStack product that does this, but there is a whole Swift business outside of OpenStack, right? So you can actually take SwiftStack. You can take Swift and deploy it without OpenStack and actually have some really meaningful use cases. You don't actually need Keystone or any of that other stuff to just, and I've done this myself, I've actually set up a Swift instance as an exercise, but a lot of the other parts of Openstack, they're sort of not necessarily that applicable to just sit there by themselves. But an object store, if you had 4 users, like the way you use databases, you have, a read user, a write user, an admin user, and you just start populating objects, and you have it over here, and you do all your distributed storage and all that sort of stuff, that's already a very useful tool, conceivably. And you can control the storage, and it's open source, and you can buy the commercial. SwiftStack is the commercial version of Swift, and they give you some bells and whistles, and they support models and stuff. But you can download Swift and run it yourself. Ceph also does object storage. It seems to be that Swift is more popular, and sort of people who know more about it than me have said it's better. But we used to use Ceph as the object storage option in New Zealand, and of course you've got AWS S3. S3 is a bit of a de facto standard because Swift actually gives you an S3 abstraction layer because they were sort of the first ones. Google Cloud gives you an object storage, Azure or Azure, whatever you want to call it, gives you objects. So there's a lot of options, and you could conceivably move these things around as you need, or as you want to make cost savings, conceivably. So there's a lot of options. First object steps in terms of if you're not using objects and you want to use them more, think about immutable objects. Think about immutable objects, things that don't change. Images, media, documents, things that don't go through a workflow, things that are static, right? Things that you're sort of just saving. Large binary objects. I mean, the database world actually sort of started the object movement with what they used to call blobs, but they still did it as a central repository, which didn't embrace the eventual consistency idea, which allowed horizontal scaling. So they've been, and it was pretty clumsy. Most of the blob implementations were quite clumsy and hard to use, in my opinion. But large binary objects, it's the same sort of challenge. Backups and archive data, like SQL dumps, really good use case for objects because they're reasonable size. You can throw them into storage, and away you go. Think about the strategy about how you might change an application that you control that's actually holding a lot of files to make it start using objects. That's actually sometimes not too hard, but it might be a lot of work. But you can try, right? There's libraries to do object storage in all the main platforms, pretty much PHP, Python, Perl, anything you want, Java. That bit is reasonably straightforward. So I've got time quickly to talk about a story, sort of an object migration story from us of taking Moodle. Who knows what Moodle is? So it's a learning management system, an open source learning management system, Australian background, very popular globally. Now, if you, out of the box, generally Moodle uses the file system. Okay, it's got a reasonably sophisticated abstraction layer and does some quite smart stuff with the file system, but it uses files, okay? And there's reasons why that's not going to change completely. It has a site data area, very standard architecture for web applications, and it gets big, right? It gets really big. With universities, it sort of just grows and grows and grows because it's sort of cumulative, and you can clean it out and all that stuff, but it's not a perfect model. So we've got some large Moodle instances. They're actually running in AWS, but the point here is that's not really relevant because we're solving the same problems you would with any cloud storage. So we've invested all sorts of effort over the years in clustered file systems. I actually did a presentation at the Barcelona Summit last year about our experience with inside cloud clustered and distributed file system solutions, as part of this is how we've solved these problems, and none of them are perfect, right? GlusterFS or DRBD or NFS, there's some elegant solutions, but none of them are perfect. They all have considerations and trade-offs. And we decided to move into object storage in this case. So one of the things that you get is, we were running Gluster, there's 2 terabytes of storage, let's say. Whenever we run out of space, we have to go and update 3 different nodes, and you can do this without an outage, but this is a physical person doing it. You have to update 3 different nodes, expand the cluster, take it out, put it in, pay more money for the bigger disk, right? And it goes up. And you're storing it 3 times across 3 different availability zones. And if you want an environment that's the same, that's a UAT environment, that's another 2 terabytes you're storing. And if you want a staging environment that also has all the data because you want to test something, that's another environment that has 2 terabytes, right? So once we moved into object storage, one really cool thing is we could actually share the objects between production and staging environments because you set up access control so that you don't delete things ever, and the staging environments have a set of credentials, which means they can't actually add objects. It wouldn't actually matter if they added objects in the Moodle sense because it's all hashed, but they can do no harm, but they don't need a complete copy of the production data. That makes we're not paying for anywhere near as much data. We're not paying for anywhere near as much storage. We get to utilize. It's much easier for us to stand up copies of development and staging environments. You can actually run this from a developer's workstation and they can still just use object storage. Like, sure, it's a bit slow, but it works, right? Now, what we ended up doing was not getting rid of file system altogether because that wasn't quite possible because of some of the small transactional files that I mentioned. So we went from we remove all the larger files, and there's some logic you can deploy, and we put them into object storage asynchronously, so that we went from 2 terabytes to about 150 gigabytes, and that won't grow very much, and we can just keep throwing files at it. So when Moodle goes to look for a file, it looks first on the disk, and then in the instance that it's not there, and there's a bit more logic to it than this, it goes out and grabs it from object storage. Now, if that's a big PDF or a media file, sure, there's a slight latency hit, but that doesn't really matter. Because if I'm downloading on my phone somewhere sitting here, then that's fine, right? There's all sorts of reasons why there'll be some latency. If that was a very small file that I needed as part of a page build, it wouldn't be appropriate. So we've gone sort of halfway because the underlying architecture doesn't support. It wasn't built with objects in mind, it's been a reasonable journey, but it's already given us concrete savings in spend and more flexibility and sort of more visibility of an audit trail of the objects that we're storing. I mean, there's more stories, there's more to it than that, but I'm sort of quite short on time. I think that's probably about it. So thank you. So yeah, any questions? I rushed through some of that, but it was a bit longer talk the last time I did it. Who's using? Oh, please, yeah. API limits as into submitting them.
As in, like, we can manifest through. They've got API limits. It's hard limits.
It's not relevant for us. No, because we're not sitting there pounding it with a million. Like, it's all a pretty gentle process. It's a gentle process of submitting and extracting. It's just a big quantity. Like the use case for the objects inside Moodle, they're not all getting pulled in and pushed out all the time. It's not 2 terabytes of stuff. Like it's almost a mildly archival workflow. And some of the things that get, and you know, AWS does some smart things, like the things that are getting requested or more often are cached. And I think we've even discussed doing some of that ourselves. So there's optimizations that can be made. But no, we haven't. And in this use case, it's not a big deal. But that's one of the things you have to start thinking about as your architecture to moving to object storage. It's not the same, right? Yeah, because you don't have to think about that sort of stuff with file systems.
The work you did in Moodle is something that can be pushed to the kernel project, so that it becomes available to any user.
To the what, sorry?
To the kernel project, so it becomes available to any user. Kind of like an SML sort of thing. So that you push.
Sorry, I didn't understand which project.
So your Moodle project where you were using object, was there a lot of manual work? Is that something that can be used by anyone?
Yeah, no. So we've released the plugin, like we've made it open source, and we've released it to the plugin. It's still getting reviewed, but
that's specifically for Moodle, not necessarily any Linux application.
it's not a blanket file system to object mapper. Those exist, but they generally have issues. There was a thing called S3FS, and I'm sure there might be it's not a good idea. You don't want to just not tell your application that they're now using objects. There are reasons why that will work very badly, because the most likely scenario is you get huge locking waits, because it doesn't know that it's going all the way back to an object store and just sits there and freezes, as file systems will do, but they don't do it all the time. And if you're writing if you're writing a 2-byte file and it waits like 3 seconds, then bad things will happen. So it's not an abstract, that's not the way to approach it. You've got to teach your application that you're dealing with objects now. So there might be latency, and there is also this thing called eventual consistency, right? So you can't ask the same question twice in a row and be 100% sure that you're going to get the same answer. Eventually you will, and that's generally not a problem, but if you haven't thought about that, then it could be a problem. Because that's not the case with the file system, right? And when we build systems, you write a file, you read a file, you write a file, you read a file. You know, the sum would explode if when you wrote a file and then you went back and read a file, it had changed. You'd be like, oh, you know, meltdown, dogs and cats living together. But but object storage, there is no guarantee. Most of the time it will do it, right? But if you write a file and then come straight back to Amazon and go, give me that file back, it'll go, we haven't got it. Because it hasn't been synced and all the magical stuff in the background, but if you come back in like 5 seconds a minute, then it's definitely there. And your application needs to understand that, so it doesn't get confused. One more question? 1 minute? Happy to discuss any of this stuff if anyone wants to chat more detail. Thank you very much.